So, good morning, everyone. So, today we are going to do the Perceptron training. Okay, Perceptron training ni if you go to Kalam, okay, if you go to Kalam, you can already see several videos that Dr. Anis uploaded. Actually, she already teach it. Okay, so today I'm just gonna go through the answers with you lah. No perception training. This one in week 13 materials. Okay, there's perception training here, the training answers and the videos. Okay, so let's see. Mana I put it. So if you download the perception training, okay, there are three questions. Okay, three questions. Answers. So I will briefly explain to you. Okay, and then the calculation you can uh, do later lah when we end this lab. Okay, so let me close this one, maximize. And then first I would like to recap what we have learned in last week. Okay, because this training actually what we already learned in our lecture lah last week. So in our lecture last week, we already learned about the basic introduction to artificial intelligence. So we learned about this one is part two. Part one, okay. So we learn about the terms that we have to get to know when we're working with artificial intelligence. So artificial intelligence ni short form dia we can call it as ANN, artificial neural network, not artificial intelligence, sorry. Artificial neural network and the short form is ANN. Okay, so last week we touched about the terms that we have to know. Okay, what is input signals, what is the weights, what is the activation levels, and the threshold function. Okay, and the basic architecture for ANN. Okay, we have the input layers, we have the middle layers, or also we can call it as hidden layer, and the output layers. Okay, for the basic architecture for ANN, like this lah. Okay, this is the basic architecture for ANN. But a few years after that, they improve the architecture and they added bias. They added bias in order to improve the results. But it's only based on data. Some data they needed bias, some data they don't. Okay. So as mentioned here, ANN it can be single layer, it can be multi-layer, and it can also be competitive layers. Okay. This is example of single layer network lah. So you have two inputs here, two weights, one bias, and then one output. So this is the formula for perceptron. Okay, this is what we are going to do today. We call this as a Hebbian learning. Okay, let me zoom a little bit bigger. Okay, we call it as a Hebbian learning. So this is the algorithm that you have to remember when you do the perceptron training. Okay, you have 5 steps here. Okay, you have step 1. First, you initialize all the weights. Okay, you initialize the weight with 0. Okay, and then the learning rate here, learning rate can be between 0 and 1. Okay, and that's step 2. Okay, you do the for statement here. Okay, for inside this for statement, you calculate the net input and the output. Okay, the net and the output. The net, you have to use this formula, bias plus the sum of input value times the weight value. So, input darab dengan weight. Okay, kalau kita ada dua input like this one, like this example, dua input, input darab weight, input darab dengan weight, total calculation tu, okay, that's what the total, the sum of input times weight plus with the bias value. Okay, that's how you calculate net. And then for output, okay, it depends on the net value. If net is greater than 0, the output will be 1. If net is equal to 0, output will be 0. If net is less than 0, output will be minus 1. So if you have a wrong net value here, it will affect your output here. Okay, so make sure be careful when you calculate your net. Okay, and then after you already have net value, you already have the output value. Step 5, if you do the comparison between the output value and the Y value. What is the Y value here? Y is the target value. Okay, so if output not equal to um, Y, okay, and then you have to um, if the statement the statement here, output not equal to Y, yes or no. Okay, if output not equal to Y, yes, then you have to create a new weight and a new bias. This is the formula to create a new weight and a new bias. Okay, new weight equal to old weight plus delta alpha here is the learning rate. Okay, learning rate. Okay, learning rate normally it will be given. It will be given in your questions. Okay, so learning rate times the target y times the input. Okay, and then you will get uh, the new weight. So wi, that means it. Let's say if weight 1 lah. So weight 1 equal to new weight 1 equal to weight 1 plus learning rate times y times input 1. Okay, so it will have weight 1 will have a new weight, weight 2 will have a new weight, both using this formula. Okay, and then for the new bias, how do you calculate the new bias is full bias plus learning rate times y, the target. Okay. Okay, once you already have a new weight, you exit the while statement here and then you go to step 6. Okay, step 6 is test stopping condition. Okay, in order to stop the testing, okay, output must be equal to the y, which is the target. That means all the output and the y value has to be the same. Let's say all y value is 1, all the output value has to be 1. Okay, in order to stop the test, or else it will be endless loop. Okay, so so far uh, this is the algorithm untuk perception training. Okay, now let's go to the apa benda ni tutup kelas. Okay, now let's go to the question. Okay, so new questions given to you from Kalam, right? So you have three questions here. All calculations are the same. Okay, so I'm just gonna go through this one. Okay, so we have the bipolar training. Why we call it as bipolar? We call it bipolar because we have negative 1. Okay, negative 1. So if it's binary, it's only 0 and 1. Okay, so the train set data below using the OR logic gate. OR logic gate, I'm pretty sure you already learned about OR logic gate, right? Let the learning rate equal to 1. Okay, remember the learning rate from the slides earlier. Okay, alpha must be between 0 and 1, the learning rate. Okay, so now we go to the answer here. Okay, so this is the answer given for you in column. Right. So when you have this kind of question, first thing you have to do is you have to create the table. Okay, first thing you have to do, you have to create the table. Okay, so in here we have x1, x2, y, and also the learning rate. Okay, this is learning rate. Mana tulis balik. Um, mana simbol? Insert symbol. Not this symbol. Symbol. Apa tak jadi ni? Whatever lah. I tulis kat sini ya. Learning rate. Okay. So, okay. We already have all this from the questions, right? Okay. We have the input, the output, and also learning rate and the target. Y here. Target here. Okay. All right. And then you put all of this information in the table. Okay. So after that, you create the the rest of the column. Okay. So we have two input here. So there must be two weights. Okay. Two weights. Okay. W x1, x2. So we have W1, W2 lah. If there are four input, that means there will be four weights. Okay. So x1, x2, then we will have W1, W2, and then we will have bias, okay, and then we will have net output. Remember from the algorithm from the perceptron slides. Skip this slides, okay, net output bias, comparison of output and target, okay, net output bias, and then compare the value of output and the target, okay, and then new weight and new bias if it's needed. Okay, new weight and new bias will only be created if the value of the target and the output is not the same. Okay, bila you compare the value of output here and our value of the target here is not the same, then you have to create the new weight. If the value of the output and the target is the same, you don't have to create new weight or new bias. Our main goal in doing perceptron training is we want to see all the target value and the output value are the same. Okay, once we achieve the goal, which is all target value and output value are the same, and then we can stop the test. Okay, that's the main goal in doing perceptron training. Okay, so for this one, okay, we will work row by row. Okay, now we go through this first row. Okay, first row we have input -1, input x1 -1, x2 -1, learning rate 1, and the target is -1. Okay, as mentioned in the algorithm here, we initialize the weight with 0, right? So we initialize the weight with 0 and bias also 0. Okay, so we give this value, okay, based on the algorithm. And then the net value, we have to calculate the net value. So the net value, how we calculate it? Using this formula, bias plus the sum of x multiplied by w. So kat sini, okay, u bias is 0, okay, and then multiply x1 multiply by w1, okay, -1 multiplied by 0, obviously it will be 0, -1 times 0 also 0, so that's why kita dapat net is 0. Okay, alright, and then after we have net, we calculate output. Output macam mana formula dia? Okay, output, if net greater than 0, output will be 1. If net equal to 0, output will be 0. If net less than 0, output will be -1. So here output net kita 0, right? So automatically output kita 0. And then after that, what is it in the algorithm? You compare. You compare the value of output dengan target kita, Y. Okay, compare. Now you see here, output kita 0, okay, and then target kita, ni stay middle. Target kita kat sini -1. Okay, does output equal to, does output not equal to the Y? Yes, it is not equal to Y. So what we have to do? We have to create a new weight and a new bias. Okay, so now we have to create new weight and new bias. Okay, back to the formula how to create new weight and new bias. Okay, new weight by calculating the old weight plus learning rate times target times input. Okay, so old weight -1 plus learning rate times target 1 times -1 times wait old weight plus, okay, old weight berapa? 0 plus learning rate times target 1 minus -1, okay, jadi -1 times input -1, okay, and then it will be 1. 1 plus 0, it will be 1. Okay, alright, so our new weight is 1. Okay, new weight 1. Okay, now you calculate the new weight 2 given the same formula. So old weight 0 plus, okay, -1 darab dengan 1, -1 darab dengan -1, it will be 1. 1 plus 0 equal to 1. So you have new weight 2 is 1. Okay, and then calculate the new bias. New bias is all bias plus learning rate times target. Okay, all bias is 0 plus learning rate times target. Okay, 1 times -1. Okay, it will be -1 plus 0. So new bias is -1. So settle first row for first input. Because we work row by row, right? Untuk Perceptron Training. So and then we move to the second input. Second input ni, since we already have a new weight here, a new weight, 1, 1 for input 1, 1 for input 2, and minus 1 is a new bias. So given this new value, okay, so that's what you have to put here. Okay, uh, the weight for this part, you have to take the new one. Okay, the new weight. Okay, so it will be 1, weight 2, 1, and then the new bias is minus 1. Okay, once you have all that, you calculate the net. Calculate the net. Okay, net apa formula dia tadi? Bias plus the total of input times weight. You guys okay kan? If you don't understand, just stop me. Okay. So you calculate lah. Okay, calculate, and then you get the net value is minus 1. Okay, now after you dah ada net value minus 1, so kita tengok for output value. Okay, now our net value is negative 1, right? Negative 1. Okay, so it is less than 0, so the output value will be negative 1 also. So we have the output value is negative 1. Okay, and then we compare the output value and y value. Does the output value is not equal to target value? Yes, it is not equal to target value. So what you have to do, you have to create a new weight again and a new bias. Same formula lah. Okay, and then done with second input. Moving to the third input. Third input, same process. Okay, you use the new weight which is 200. Okay, so you will use 200. Okay, the new weight and the new bias. Okay, use the same formula to calculate net. Okay, you get negative 2. Okay, and then you compare the net value. Okay, net value is less than 0. That means it will be negative 1. Okay, and then you compare the output and the target value. Okay, does output and target value is not the same? Yes, it's not the same. Then you create a new weight and a new bias. Okay, and then done for third row. Moving on to the last row. Moving on to the last row. Okay. Uh, we use the new weight lah. The new weight here. Uh, New weight and a new bias here. Okay. And then we have new weight. Okay. New bias. And then we calculate the net. Okay. We calculate the net given the same formula here. Okay. We calculate the net and then we have net is 3. Okay. Now to get the net. So what is it? To get the output. Okay, if net greater than 0, output will be 1, right? Okay, so output 1. So now you compare output value dengan target value. You compare. Oh, it's the same. Okay, so the statement here is not correct lah. So output does not equal to y. Okay, it is equal. So once you have a no here, once you have output and target same value, you don't have to create any new weight or new bias. Okay, so you are done for the first training set. And then you have to move on to the second training set. Repeat the process again. Remember, our goal is we want to get all value of output has to be the same value as target. Okay, ni kita punya target, right? Minus 1, 1, 1, 1. Kita nak all our output value here all same dengan target. And then when we do comparison, all the statement must be no. That's our goal in order to stop the test. Okay, so you're done with the first test set and now you have to move on to the second test set. Okay. For the second test set, you copy balik je. Just copy S1, S2 learning rate and the target. Okay, and then you take the last updated weight value and bias value here. Okay, the last one. So we have 1, 1, 1. So you put 1, 1, 1, and then you calculate the net value. Okay, calculate the net value, you will get negative 1. And then you compare for the output value. So output value, if net less than 0, output will be minus 1. Okay, so you compare the output and the target value. Minus 1, minus 1. Does the output not equal to y? No. Okay, so no, so you don't have to create a new weight. And then you continue. Continue with the same weight value, 1, 1, 1. And then you calculate the net, and then you get the output, and then you compare. Okay, 1, out, target is 1, output also 1. No. Okay, and then um, you do the same process again, and then you get all no. Okay, you get all no. All the value for output now is same value for output, and value for input is all now same. And then you can stop the test. Okay, so you write test stopping or vectors is okay. Okay, that means you are done for this training, for these questions. Okay, and then that is for the bipolar training. And then try to do the same thing for binary training and the binary training with bias and binary training without bias. The process is the same. Okay, the process is the same. You try do it on your own, all this exercise, and let's see if you have the same answer or not to check. Okay. So for binary training here, binary training with bias, right? Binary training with bias, you do all the same step also. But you can see here, even after 4 test set, okay, you still could not get all no. You see, you only get yes, no, 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 yes, no, 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 yes, no, 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 no. And our target for the for perceptron training, we want to get all no. Okay, so given this situation, that means you will not achieve the target, and the answer will be endless loop. Okay, you tried 4 times for four input, 4 times 4 test set, and then you get endless loop. Okay, that's for the second question here. And then for the third questions, binary without bias. Binary without bias, the difference is you just remove the bias. The bias, uh, the bias, what is that? The bias column. Okay, so we don't have B column here. The bias, just remove it. The process is still the same, except here. When you calculate the net here, you just ignore the bias. You just do the sum of x times w. Okay, the sum of x times w without the bias in order to do this question. Okay, for this question, you do the same process. Okay, compare the output and the target value. Okay, and then once you get all the output and target value, same value, okay, and then you stop the test. You stop the test, all vector is okay. All right, so is everything okay? Did you understand? I think it's very easy, right? I think you guys easily understand. But remember to really understand, because these questions will be in your final exam. Okay, so try to do the exercise on your own. Okay, try to remember. You have to remember the formula. Okay, macam how to calculate the net here, how to calculate the output, okay, how to create the new weight, how to create the new bias, okay? You have to remember because it will be in your exam. Okay, all right. So if there are no questions, I would say that's all lah for the lab today. You already have the answers. You already